There we go. We are both with a company called Sodero Labs, and we started by our founder creating something called Talos Linux, trying to solve problems for Kubernetes. It's an operating system that works exclusively on Kubernetes. It's small, it's immutable, it's fast, and after that, we came out with a product called Omni, which is a SaaS version, kind of pulling all those Talos Linux nodes together. And Tim's going to talk about, you want to introduce yourself?
Sure. Hi. Yeah, my name's Tim, as Kim was saying. I've been with Sodero now for like 4 years, nearly. And I was actually a member of the community beforehand. Talos is completely open source. It will remain so as long as we have any sort of foresight and thing. Omni is a paid product, but it's under the Bustle license, so you can use it for non-production things without a problem. And yeah, we've been working on making Talos easier to use. All of our own Kubernetes clusters run Talos. We dog food pretty much every part of the company. And since developing Omni, we've actually migrated all of the clusters we use to host things into Omni itself. It's that much of a time saver for Kubernetes. So yeah, that's just what we've gone over. And so some things we need to make sure so we're on the same page about before we go. Talos is the operating system you install on your computer. Omni is the management platform that manages all of your Talos systems together. You can build one cluster, hundreds of clusters, it doesn't matter. You need one Omni and lots of Talos. And that's like the basic, if you come in with zero information, that's what you need. So, biggest problem. Getting up Kubernetes starting is slow, it's error prone, there's lots of semi-automated processes by it. You know, the most famous one being Kubadam, but obviously each cloud has their own way of doing things and they're all different and they all bring or don't bring different things. EKS, you know, you get their CNI, but you get no storage, you have to install that later. It's inconsistent, especially across providers. It can take a long time to get set up. And then responding to those problems, if you need to spin up a test cluster for like reproducing an error, you run into all of the same problems again. So with Talos and Omni, all of your system configuration is machine defined. Not only the processes running on your machine, but the entirety of the cluster itself is machine defined. So you have everything you need at the end of a command. It's all API driven. It's completely automated for the cluster setup yourself, and the operating system as well. If you define block devices, you define them in a static machine config, and Talos takes care of actually setting up your mounts and your disk partitions and everything like that.
Well, and I will say that you can go to your demo. I mean, Tim is talking specifically about what our products do to solve that, but when we look at these problems, we're also, I mean, these are solutions that you should be looking at in any sort of operating system or SaaS environment on trying to solve these problems. So we are giving examples of our products because our employer pays us to do that, but make sure you're looking at that in any sort of solution that you're looking for. And if you have questions as we're going along with each one of these challenges, be sure to raise your hand and we'll take Q&A throughout as well. Okay, go to your demo.
So yeah, we're just going to go through a quick demo now of how to set up a cluster with Omni. It is pre-recorded. They wouldn't let me do a live one, being an engineer, but if you want to come to the booth after the talk, I will absolutely do one live if you like. Okay, so when you first start up Omni, you get a very simple dashboard. You can select which version of Talos you want, which platform you want, and you can see here we support all of the big three clouds, Hetzner, UpCloud, a lot of other things, but the simple option is an ISO. Here you can see the different system extensions we support. So Talos being immutable, if you want like extra drivers or another service running in Talos, you have to compile it into the image before even running it. We do support secure boot. We also support booting Pixie directly from Omni if you're running on bare metal. You would click download, but I haven't done that on the demo. But that's what you would get. You would start up your machines, and they would appear in Omni as machines with metadata, with labels, region information, and you can see all of that. Then we can just create a cluster. Very simple click through. We can give it a different name. Look at that, super easy. We have different options for your cluster encryption, workload service proxying. And here we can just select one control plane, a couple of workers, and there we go. It's off creating the cluster. Just those few steps. I will skip through on the time a little bit now because it takes a little while to install and everything, and you'll see things flick through. Like normal installation time, obviously depends very much on the hardware you're using, but it can take anywhere from like 5 minutes or less on VMs to 20 minutes if you've got a big bare metal server with lots of memory to check, and it takes 15 minutes just to post. So there you go. A couple of time skips later, the worker's up and running. The control plane obviously has a few more components, and there you go. It's done. It's up and running. You have a regular Kubernetes vanilla cluster right there, and you get some nice overhead of different information. Now, again, we are an API-driven company, so I'm going to basically do exactly the same thing over again now, but do it as if it were like a GitOps operation, because ClickOps is not a thing people want to be doing every day. You can do it with Omni, but there's no need. At the top there, you have what we call a cluster template, which is the definition of the shape of your cluster, the Kubernetes version, the Talos version, how many control planes you want, how many workers you want. And you can see the command is a simple sync, and it's gone off and it's actually built the exact same cluster with far less work. And obviously, this is the sort of example of the power you have with API-driven operating systems. And again, it's just going to skip through a few time skips, and it's going to come up ready. And that's how simple it is to get a cluster up and running with Omni and Talos. Did I time that right? Almost. So I'll just wait for that to... There we go. Almost right. So next challenge. After you've set up your cluster, obviously lifetime maintenance becomes a lot more work. When you are running a cloud managed service, sometimes you don't even get a choice of whether you're upgrading or not. Other times, if you don't upgrade at the cadence that the server provider wants you to, you end up paying vast sums to stay on an older version, things like that. Upgrades can be unpredictable when you need CVs changing, when you need CVs fixing, I should say, and when you need to actually run the workload, shift them up and down. For instance, if you're using CAPI, Cluster API, to manage your cluster, you can't do in-place upgrades at all. You have to have spare capacity to bring in new servers at the new version and then shut down the old versions. And if you're running on a budget, you might not have that overcapacity. So upgrades from the Omni perspective are, again, completely declarative and completely API-driven. Omni allows you to manage at a fleet-wide level. You can manage, it doesn't matter if it's like 5 machines or 5,000 machines. It all gets managed in the same way. It doesn't matter if they're in the cloud, in a data center, or Raspberry Pis hanging off the end of a phone line in some far-off land. It's all run the same way. It's all run via APIs and all managed for you by Omni. It does things like making sure that the previous machine is up and running fully before moving on to the next one, for example. So here we're going to run through another demo again. And again, I'll do the same thing where I'm showing you how to do it through the UI. And you can see there's several versions of Kubernetes to upgrade. And you can literally just, from the list, select which version you want to go to, hit upgrade. At this point, Talos actually does a lot of checks to make sure you're not using deprecated APIs, you haven't got resources in the cluster that could fall out of use with your upgrade of Kubernetes. For instance, if you're still using the very old ingress definitions, things like that, at this point you would actually get an error saying, hey, you've got to go fix this before you can upgrade to that version of Kubernetes. That's actually handled because Talos is dedicated only for running Kubernetes. Then we can have upgrade paths that check for viable upgrades before going through it. And if this was, a HA cluster with multiple control planes, you would actually see it go through each control plane in turn first before even moving on to the workers. But since it was just a demo, unfortunately, you see the cluster technically go into a non-ready state as it updates each component. One of the things Talos does is it also makes sure to download all of the images that are needed for the update before proceeding with the update. So you won't get caught if you have an edge node at a very poor connectivity site. You won't have the problem of an upgrade starting and then it trying to pull down the new kubelet or the new API server, things like that. All of those are pre-pulled before upgrades even started. And again, you can just see it flicking between ready and not ready as it downloads and updates each component in store. It does, the Kube API server separately, the Kube controller separately. All of these things are checked to make sure that they're back up and running in a healthy state before moving on to the next component. This is things of, if you manage your own control plane, these are things that you would need to do yourself, whereas Omni just takes care of it for you. There you go, the control plane is up and running, and now we see, like you didn't even see the workers upgrade, because that's just the kubelet restarting, and it takes almost no time whatsoever. And now we're just running through an upgrade of Talos itself. So this is the operating system being upgraded underneath Kubernetes. It's a slightly more involved process, but Talos does do dual partitioning. So you're running on partition A. When you do request an upgrade, it downloads the new version, installs it to partition B. It then restarts on partition B. If your upgrade for some reason doesn't come up healthy, something's changed in the Linux kernel, your network device names have changed, things like that, disks can be enumerated differently, it will stop, reboot, and go back to partition A, so you'll come back into a healthy cluster. And you can see this process is a bit more involved for the workers because they still need a reboot as well. And and you can see the status at the top as well is showing you that it's going through an upgrade currently. And you can see that it's making sure that it only takes down one node at a time. So as long as your workloads are flexible to node loss and things like that, you should actually see very little downtime at all. And that's that demo. And there we go. So again, one of the big benefits of having all of this be defined, structured machine data, API-driven, if you need to, most of the time people want to have multiple clusters for production, for staging, for testing, and it's much easier to make sure that your cluster configuration is at the same level in all of those environments with Omni and Talos. Because again, you just define how your cluster should look, you should define the structure of it, and Talos and Omni will create exactly the same thing time and time again. Obviously, you still need to do your workloads with something like Argo CD or Helm charts or whatever. You still need to find what's running in the cluster by your own methods, but the configuration drift of your environment, of your cluster itself, of your hardware, is practically eliminated with Talos and Omni. And I'm going to do the shortest demo, and this is the shortest demo because it's really, really hard to show how incredibly powerful a copy, paste, and sync is. And that's literally what we're doing. We're going to be duplicating the environment just by copying and pasting those files. So here we've got a production environment up and running, and say I want an on-demand development environment, I can literally just go to the production cluster template I have, copy it, put it into testing cluster, if I know how to type. And all I'm going to do is, once that comes up, change the name. There we go. So we change the name from production to testing. So that tells it it's a different cluster, just like with Kubernetes resources themselves. And then we sync that to Omni. And Omni goes, OK, I'm creating a brand new cluster now. And just like before, because it's all API-driven, because it's all machine-defined, it will create a new environment exactly as the first one. If you have special drivers, if you have like NVIDIA GPU drivers because you're doing AI workloads, if you've got special Mellanox network cards and you have the drivers for those, this will duplicate that for you. And you see how quick it was. I couldn't even get through it. And that's all it's required to just duplicate. You can create environmental clusters on demand. You could actually have your CI process creating a whole new cluster, testing your stack, and then push it to staging if you like. And one of the last challenges is how do you keep everything secure? General purpose OSs, like Ubuntu, Red Hat Enterprise Linux, they always leave, their general purpose, they have to be able to do a lot of things. So there always are parts of the system that are vulnerable to security. Things like even having a shell available on your server, it encourages people to go, oh, I just need to do a quick fix. I just need to SSH in and rotate this log file. And that will lead to drift, it leads to inaccuracies, and it leads to differences in production, the staging, and it can cause lots of problems. So yeah, Linux, Talos Linux is less than 50 binaries as opposed to Ubuntu, which has like nearly 3,000. That is, by simple numbers, a smaller attack surface. The only major CVEs we've been affected by are ones that have been in the Linux kernel itself, which absolutely every Linux operating system has to deal with. By prioritizing immutability, atomicness of the operating system itself, it removes the management of these issues. You don't have to update your Linux kernel anymore. You just update Talos. Talos will then update your kernel, update containerd, and all of the only 50 components that it needs to manage are all built from source, and they're all built by our secure pipeline to keep everything running. And now we've got a fun little video to show you how much better those. And no audio. But you can read it while it's going on.
To run a node in a Kubernetes cluster. A lot of people will start with a general purpose Linux. This is Ubuntu server 2204. That's over 2,500 binaries with no packages installed. How about Flatcar Linux, built for containers? Over 2,300 binaries in this operating system. Amazon Linux too. Over 1,700 binaries. Now what about a Linux distro that's built for Kubernetes? That's 12 binaries in Talos Linux. Orders of magnitude smaller than any of these other systems. There's no amount of reducing the size of this OS. All we actually need to run a node in a Kubernetes cluster. This is more secure, it's faster to do updates. You can actually understand what all 12 of these binaries do. Don't take a general purpose Linux and try to reduce it down to size.
Yeah, I think we're up a little.
So yeah,
higher.
obviously it's not quite 12 anymore. When the video was created, it was just 12. We have got more features and more technical ability now, so it's bloated Talos by 20 odd binaries. It's crazy, but it does show the comparison between the operating systems there.
That's how we have the jelly beans.
Sorry?
That's how we have the jelly beans.
Yeah, if you come to our stand outside, we do have jelly beans to show visually the difference
visually
it is.
show what Justin did with beans are a lot lighter than jelly beans to travel with. If anybody was wondering. Go ahead.
Sorry. So other benefits you can have with running Talos and Omni. Multi-card provisioning. I haven't really touched on this much, but when you saw that drop down of all the platforms Talos supports, that simultaneously you can have hybrid cloud, hybrid environments. You can run control planes in Azure and workers in Google or bare metal. You can really mix and match whatever you like. We created one time a global cluster with people from the community, where some people were running Raspberry Pis, some people bringing Proxmox VMs, some people bringing big HP enterprise servers, and Talos was configured the same for all of them and ran the same for all of them. And that's one of the really big, powerful parts of Talos. It is a single operating system with a single use, and therefore can adapt itself to multiple environments. We do also support completely air-gapped cluster discovery.
That means
Is
you
that my
got
time?
questions.
And yeah, we've got some
questions.
Yeah, hang on. So thank you.
So is Talos the operating system where
Sorry,
Kubernetes
can you
is running
talk
on?
up a little bit? I'm partially deaf, so I need you to really shout.
Okay. So is Talos the operating system where Kubernetes is running on, or is it like my base layer in my container?
No, Talos is the operating system running on the hardware, on the hardware or on the virtual machine, and Kubernetes runs on top of Talos.
Okay, thanks.
Any other questions? Okay, thank you. Oh, yeah. Thank you. Come to the booth if you have more questions. Thanks to our sales guys.
Thank you.
Thank you.